Good morning, everyone. Welcome to the second day of the North American IPv6 Summit. Glad to see you all again. Just thought I'd make mention, Chris Tuska from the Rocky Mountain IPv6 Task Force and ARIS helped us put together these shirts with Gretchen from LinkedIn and with Stephanie. And I don't know if you know, but there's a secret phrase here in the shirts. There's actually 4 different secret phrases. So we'll give you, we should have told you yesterday so that you could try and figure it out throughout the day. And if you can't figure it out at the end of today, we will, we'll just tell you what it, well, we won't tell you. Okay, it'll be a secret forever.
I didn't even encrypt it because if I would have encrypted it, that would have been a lot more fun.
Yeah. So thanks to Chris and Gretchen and Stephanie for putting together such awesome shirts for us this year. So thank you. Yes, thank you. So, speaking of Stephanie, I think we mentioned yesterday, you know, how Stephanie's really been instrumental in helping us put together this event. And so the North American IPv6 task forces have put together a letter that we'd like to read.
So we'll be presenting and sending you a more formal copy of this, but this was, you know, late night musings.
We'd write something, we would present it, we would submit it to LinkedIn, and then we'd probably put it on your LinkedIn profile.
So if that's okay.
If that's okay.
But the North American IPv6 Task Force wants to publicly express our appreciation to Stephanie Schuler for her outstanding contributions to the IPv6 community. The IPv6 community is indebted to LinkedIn for opening their Sunnyvale, California facility for the 2017 North American IPv6 Summit on April 25th, 26th, 2017, obviously. However, our event would not have been possible without the tremendous efforts of Stephanie. Those of us in the IPv6 Task Force are volunteers, and we expect to perform the vast majority of event planning for our IPv6 conferences. We're thankful to Stephanie and for how much coordination and planning of the conference details she did on our behalf. Her contributions include, but are not limited to, venue scheduling, room setup, event security, catering, audiovisual, session recording, parking, t-shirt design, press releases, marketing coordination, and numerous other activities. This on top of Stephanie's active involvement as a technical contributor to the IPv6 community. She's been a wonderful resource. We thank LinkedIn for allowing her to give back so much to our technical community. We truly appreciate all the work that Stephanie Schuler has performed to help make our IPv6 conference a reality. And for her individual contributions to the IPv6 community, we're presenting Stephanie with this recognition award to express our gratitude for her past and ongoing contributions to IPv6. So thank you very, very much. And with that, you have to step up. And if someone can snap some photos for me, because I'm not pulling my phone out, so yeah. Everyone pull your phones out. and take plenty of pictures. So I will stand over here. Oh, Owen's right up in front. Awesome. You should open it up. Take a glance at it. Hopefully not drop it. So thank you very, very much. We deeply appreciate it.
So now, introducing Stephanie Schuler.
Who is introducing Frank Martin. So Frank is French, as you'll hear from his voice in just a moment, but he came to us by way of Fiji. He'd spent 20 years in the Pacific Islands there, wearing all the hats, because that's the way it is in the islands. Setting up ISPs, even establishing country code top-level domains for Kiribati and Nauru. He was trustee at the Internet Society from 2006 to 2009, and he's a member of the San Francisco chapter and the Pacific Islands chapter. He's been here with us at LinkedIn since 2011. He's passionate about IPv6. So he put LinkedIn Mail on IPv6 very early in order to shame the other applications into doing it. Because if you can put mail on IPv6, then web apps have absolutely no excuse. He's chair of our IPv6 Inside the Data Center working group. And the team has a new name. It is the Quad A team, also known as the IPv4 disposal experts.
Good morning. So what I will be talking about today is a little bit our journey on IPv6 at LinkedIn. So you all saw this one. Let me move the mouse away. We also this one is that here at LinkedIn, we look at 2012, we say, okay, the world is going to run out of IPv4 address, what we are going to do. This is Jeff Houston's prediction, and the prediction became right in 2015. The ARIN didn't have any more IPv4 address to hand over. So we were looking at this prediction and we said, okay, we need to start to move. So we did like everybody. The first thing is that you put your service to the consumer over IPv6. And as Stephanie was mentioning, we had at the backbone on IPv6, so that was Zed Ali, was then at the time director of network operations, said, well, I've got my backbone on IPv6. No, we need to move some application. I said, well, I'm in charge of the mail. I control them, so I'm going to put them on IPv6. So that was the first application. There were not too many people to convince, and we did it. The part that you see is that we put also the site 1 year later on IPv6 that require more team coordination because you need to move the IP address all the way to the backend and into database, etc. But basically, this is things that everybody does, is that you put some form of proxy in front of your servers that will serve all the IPv6 requests and then overhaul in the backend to IPv4 as usual. So we did that. We did the mail. Just a side note, when we were on the mail, then we put the high-level requirement that you need to have SPF and DKIM if you want to email us over IPv6. The industry, we all got together at the industry, and we adopted this standard. So if you want to email over IPv6, make sure it's SPF and DKIM because bad things will happen. It's an opportunity, as John Curran was saying, to take a chance of a new network with new entrants to make it safer and a better internet. At the same time, to allow our people to test, and we deploy IPv6 in all our office so that people can experience it and be able also to experience our website over IPv6. So we saw over the years the traffic grow coming to our website. So this follows the usual curve. We saw also that IPv6 is faster than IPv4, and we see that today we had the presentation from T-Mobile that most of the mobile providers in the US have moved to IPv6 only network. When I say IPv6 is faster than IPv4, I think there was some slide from the Akamai presentation. Facebook did some analysis, we did some, Apple did some also analysis using their system. What we do is end user testing. So we check how the user, how the session is performing across various devices. John Curran said that, well, maybe it is today, maybe it won't be tomorrow. What's important is that it seems that maybe the IPv6 is an open US highway. There's nobody on the road, but now it's getting more and more people. It's getting congested. But the important thing is that with metric and measurement, then we can hold all the parties to say, hey, we have had great performance and we see it decline. Fix it. We don't have to take the internet as it is when we came on IPv4. This is how things are. Now on IPv6, we see it better performing. Now we can hold accountable everybody to say, well, we want to keep this performance. So do whatever you have to do to keep this performance and hold everybody accountable. And we have an A/B testing because it needs to be better than IPv4. So you can compare things. So look at your number, instrument everything so you can measure all these very important things. It's quite important to be able to see this information and to be able to keep track and get to the providers, vendors, CDN, etc. As the conditions are changing. This is our heat map. Who was it? I think that was Cloudflare that showed also a similar heat map where people are connecting over IPv6. So I don't think it's much surprise for you. This is where we see most of the people coming with IPv6, the red part. Then we started to look back in 2015 and we said, what about our internal network? Then we realized that the way that we are consuming internal IP space, we are going to run into problems. And we saw that our internal IP space, even that 10/8 is a lot of address, we are going to run out. This is a rate of decline of our 10/8. So we are in RFC 1918, in private space. It's not even the public one. And we see that's our rate of decline. So we say, well, we need to do something about it. So options, we can extend the life of our IPv4, or we can bite the bullet and migrate everything to IPv6. So we established this IPv6 DC work group. And we say, OK, we are in the plan of building a new data center and say, OK, well, let's build it entirely IPv6. And then from there, then we'll start to see how we are going to build it IPv6 only, other data centers, or migrate to it. So Oregon got built entirely dual stack. There's a caveat here, is that we didn't put any Quad A. So all the stack is there. We have got IPv6, IPv4 on the stack. We didn't put any Quad A because we wanted the infrastructure ready, but we needed to have all the engineering and software to be able to migrate in their own way. So the infrastructure were well ahead. We put our infrastructure like DNS server, mail, NTP, etc. from the infrastructure people that we control over IPv6, but we need to move also with all the engineering team and all the application. But we build a very solid foundation. So why IPv6 in the data center? The thing that we saw in our usage of IPv4 is that we share the same space as our office. So as our office grows, then they use more IPv4, and you need to be able to reserve enough space to allow for this office to grow. We also move from normal computing, so you've got one server in a 1U or 2U, to dense computing, where you stack multiple servers in the same 1U unit. And then we are looking at going containers. So now you have got many devices, in a single rack. So you're expanding the number of devices that you're putting in your data center. So this is why we saw this increased usage of IPv4 space. The other thing is that, sometimes when we talk about the IPv4 exhaustion, the whole reaction, well, maybe we can extend, maybe it wasn't allocated properly, maybe we should have done it differently. OK, whatever. The other thing that we see in IPv6 is that it opens up opportunities. We don't have to worry about IP space. Once you've got a /64 on a rack, there's plenty of IP space to do whatever you want to do. Even on the network side, we've got enough network. We can overlay several networks per rack. We've got opportunities. We are not constrained by the range of IPv4. And that's something very interesting that people are saying, oh, I can go into this area because I don't have to play tricks. The other thing is when you are doing IPv6 is that you can provide end-to-end connectivity. So if you would have to expand, then we would reuse IP space. The same IP space in every data center, or the same IP space in every office, and have some kind of proxy gateways to convert from one packet to the other, do NAT 4.4, etc. Here you've got end-to-end connectivity. It doesn't mean that you can reach every servers in our data center over the internet, but we have got the capabilities of deciding what can connect to what. That's very important. At least the network is routable. We put ACL, firewall, and all kind of things. But at the network level, it's a final decision of decided what can connect to what. You don't have to re-architecture, re-engineer things. So just a reminder, this is something that, when we talk with engineers and software engineers and other people, then they've got trouble to comprehend and they have trouble to understand the difference between a local link and a global link, and the fact that you can have multiple IP address per interface. You don't have to create this virtual interface. So this is usually a slide I put to them. So for traffic to go on IPv6, your client needs to have a global IPv6 address. Your server needs to have a global IPv6 address and be discoverable on the DNS. So we use these things to put IPv6 everywhere first, and then as the application are becoming IPv6 compliant, then we can start to put queries and move the traffic over them. So I see, I'm going fast. So we kind of see also three pillars in the deployment of IPv6 in the data center. So the first one is your network. Are you going to have static, dynamic address, the ACLs, all the things that builds your network. You've got the hardware. Very important for us is that we've got a lot of servers and we don't want to spend time to configure them manually. So everything has to go automatic. How you are going to build these servers automatically on an IPv6 only network? What solution do you use? How you are going to control and manage these servers over the wire? Even if the server is switched off, you should be able to connect to it and switch it on. That's management interface. Software. Then you need also to look at all the software, all the pieces that you have. How you're going to discover service. Which one are IPv4, which one are IPv6? I do have a client which is IPv4, which client which is IPv6. How do I connect a IPv6 only client to an IPv4 only servers, and all these kind of things. Connect strategy, and you have to upgrade, and re-upgrade. So you deploy a version, then a new version, and then until you get it right. And as I say also, you need to also support legacy IPv4 software. I tell everybody, we need to move to IPv6. It's fine an exception, but you need to justify it. We know that not everything can move to IPv6. We see it in the other presentation. The fun part is when somebody is telling you, well, we move everything IPv6, and the first question is, why you couldn't move? That's an interesting question. So you need to be able to support legacy software. So let me get a bit in detail on the various pillars. So on the network, we build statically. So the IP address of the machine is decided at build time, and it's static, it's servers, they are not moving around. One tips that our friend at Facebook gave us that they would have liked to do it, so we did it, is you put the gateway on all the rack at FE80 column 1. We found some piece of software that were not happy with that, but in general it works on Linux and routers, but some gateway don't like, some system doesn't like to put this stuff. It's quite rare. But the advantage is that you have got a standard gateway wherever you are. So if you want to see if you have got network connectivity, you just ping this one. You don't have to figure it out. Where is a discoverable gateway? You don't have to look into the routing table to see which one is it. You don't have to look for router advertisement. It's a very standard environment. So we know that we have IPv6 connectivity if I can ping it. Tools. In a network, you've got a lot of tools. It's not the operating system, it's all the tools that support the operating system and the server that are important. does your stuff run on this operating system or on this operating system? It doesn't matter. Do you have the tool to support it, to get my metrics, to get all the information, to monitor everything? So you need a way to convert all these tools, all these rules, ACL, etc., from IPv4 to IPv6 without having to ask everybody or our release engineers to please come back and re-enter all the ACLs in IPv6 now. So this is why we devise a kind of a mapping between v6 and v4 that we found useful. So we've got a system that describe which network is assigned to which cab, etc., and we pair it with an IPv6. So we've got a method to say, well, if I've got this IPv4 address, I'm therefore in this rack, and then the IPv6 network which is configured in this rack is this one, and from there I can devise the IPv6 address. So when you have got an ACL that say, well, this machine can talk to this machine over port 80, then the IPv4 rule is getting generated, the IPv6 rule is getting generated automatically. We could have used DNS records. That's another way with reverse address. But because we went first the way of deploying IPv6 address without the DNS, then that was an easy way to get all this mapping and tools. So that solved a lot of problems because the ACL are here. From a security point of view, if the communication is authorized on IPv4, it's authorized on IPv6. The VIP can be created automatically as long as you've got the right information. So that's an important part is, think about your deployment of IPv6 with all the tools that you have at your disposition so that you don't have to go and revisit everything manually. You can have function to convert automatically all the rules that you've set up, all the configuration that you have set up. That goes on all the machine. Hardware. So that's the fun part. How do you provision a device over an IPv6 only network? So I think the Cisco folk in Building 23, hinted that all their network gear, they were provisioned over IPv6 only. For servers, it's slightly more difficult. So you've got Pixie, and you've got BIOS, and the people that are making the BIOS have said, now we are not going to support IPv6 in legacy BIOS. You need to move to UEFI. So you can do a UEFI network boot over IPv6. All right, so your network interface needs to have the right firmware to be able to pick up an IPv6 address. Will they support SLAAC or DHCP v6? Questions. When we are on IPv4, we tend to get our IPv4 for imaging the machine over DHCP. If they don't support DHCP v6, then we need to architecture our system to support SLAAC at build time. Will the UEFI say that they can also support HTTP versus TFTP? TFTP is great, but nowadays when you are trying to ship very large image, it's not so great. When you are trying to bootstrap a data center from another data center across continent, TFTP is sometimes fun. So HTTP is there, but will the UEFI that you're having will support HTTP at this level? Is it in your firmware? So you need to start to talk to your vendors. We got some firmware, and we made it work with Grub. So also on the open source community, Grub support IPv6 imaging. But it's a little bit weak because the people in the open source community don't have too many machines to play with IPv6. So important, give IPv6 in home so that all the people in the open source, does Linus has got IPv6 at home, and does he try to boot his Linux servers over IPv6 so he can fix all this stuff. So that's the part which is important. People need to have an environment where they can test this stuff, and that needs to be second nature. So Grub has got IPv6 support, but it's a little bit weak. I think they are supporting only SLAAC. They don't do DHCP. So there's still a lot of effort to be done there. I think you've got another bootloader, IPXE, which is a little bit more supported. But if you've got an infrastructure that uses one, moving to another one is some effort. So we still need to do a lot of effort in bootloaders. The third part is you need to be able to manage this machine over the network. I don't know, the lightouts or whatever, the management interface. So you need to be able to see what's on the screen without having to go there and put a screen at the back of the server. So that's management interface. Okay, so you can see remotely when the machine boot up what shows on the screen, what's the BIOS and why it doesn't boot. You need to be able to access the machine when it's running so you can, repower, cycle the machine, do a lot of things. So this is what we call the BMC, IPMI. IPMI tools are on Linux. And there's a new standard which is called Redfish, which support IPv6. Okay, so does your firmware has got Redfish with IPv6 support? Once again, will the management interface get an IP address via DHCPv6 or Slack or both, or whatever configuration you like, options. IPMI tools that we see on Linux, well, only the last version that they just released, I don't know, maybe a few months ago, has got the new command, which is LAN 6. So if you're familiar with IPMI tools, you've got IPMI tools LAN, and now you've got IPMI tools LAN 6 to configure your IPv6 side of this interface. So this is new. So you may not find it in your standard OS release. Before a new package finds its way in the standard release, it may take 6 months, a year. So we may need to compile ourselves this release and include it into our stuff. So this is very new things. The final part is that firmware are highly dangerous. We don't want to have a collection of bricks in a data center. So we want the servers to ship with the right firmware. To ship with the right firmware, we need to first make sure that the firmware works in our environment, and then we need to certify that there's no bug that's going to appear at scale. And finally, we need to put an order to the vendor and say, well, we want all this new server to be shipped with this type of firmware. So that takes time. And the server that you put in your data center may be there for the next 3-5 years. So if you don't start now, then we can't deploy IPv6 only servers for the next 3-5 years. So we can flash. We can take the old servers and say, OK, well, we are going to upgrade the firmware. So that means that we need to evacuate all the applications that are running on it. We need to be able to flash. We need to be able to bring back the machine. We need to make sure that the flashing is not creating problems. It's not impossible, but it's difficult. Maybe you've got servers which are old, 1 year old. And the vendor doesn't want to develop a firmware for this version that they don't support it. They are looking at building the new stuff and releasing it. So what do you do? What do you do with your infrastructure? How you're going to convert? So this is the part that I always try to talk to people, is that help us by talking to your hardware vendors and say, well, do you have the firmware to support IPv6? Can I provision these servers? When we do Office, it doesn't matter. Your Mac is going to be built on Mac or Linux, Windows, whatever you're using. You've got people, and they can have an IPv4 network and build it or manually configure it. Some Office has got a lot of employees, so they need to do it at scale also. But in this environment, you always find IPv4. If you do IPv6 only, then we need to go all the way. So talk to your vendors. The more people talk to their vendors, the better and the easier it will be for all of us. This is where we want to have the infrastructure at this level to be on V6. The little snapshot on the top is just to show you, yes, you can boot a server over IPv6. And it's difficult to see in all the documentation if you can do it. talk to your account support and say, do you have IPv6? And they say, well, I don't know. Well, can you try to put a server on IPv6 only and see if you can boot it? Oh, well, this kind of conversation needs to happen. Software. So first thing is that make sure that all your services are listening on IPv6. So inventory everything. Different language, different ways of making them listen on IPv6. Different language, different way of supporting IPv6. Maybe you need to upgrade to a new version of, I don't know, Python tools, Python tools, Java, whatever. You need to look at all this underlying language and see how they are going to listen on IPv6. Look in the code also to make sure that there's no IPv4 address that's sneaking in. Somebody put 127.0.0.1 instead of putting localhost. Or using the IPv6 any to listen on any interface. I think this is the one. One way also we saw about it is at the connect strategy. So which connection strategy you are going to use between your client and your service. And I think we had a discussion between people. So you've got several versions. You cannot fail. I'm trying to connect on IPv6, it doesn't work. I fail hard. The application client server cannot work. The OS is saying that you should be able to, but for whatever reason, there's an ACL in the middle, there's the route is not set up, the gateway is improperly configured. It doesn't happen. You hard fail. Advantage is, well, it failed, you have to fix it, and it's going to be fixed very quickly. Disadvantage, well, it failed, and then you create an outage, people are not happy. You can fall back. So you try to connect to all the lists of IP address that you've got for the host. You've got IPv6, you've got IPv4, you may have several of them. Eventually, the IPv6 doesn't work, the IPv4 work, you connect. So you don't create an outage, but you have got degraded performance because you had that to fall back. When you do multiple connections per second, then this degraded performance is showing up very fast. You don't create the outage, but you need to be able to monitor these things. Or you could also use IP eyeball or a version of IP eyeball. So you don't create outage in your system. People are feeling more confident to move the application to IPv6 because it doesn't ripple effect. Problem is that if you don't notice it, then you may never fix it. Till you start to remove IPv4 and then you discovered, oh, this stuff was always running on IPv4, it never ran on IPv6. So these are all the various connection strategies that you can use between your client and service. I leave it option to the software engineers. I say, well, if you go all the way to IP eyeball or fallback, please make sure it's instrumented and monitored so that an alert is raised to say it's not happening as it should, so we can go and fix it. For instance, one example, so we are a very Java shop. One thing which happened in Java is that there is control inside Java for the preference of IPv4 versus IPv6. So Java overrides the OS settings, which is somehow useful because then you can convert the infrastructure. Different teams, there's the infrastructure and then there's the engineers. So you can convert your infrastructure and then let the engineers or the release manager to do the conversion on the way. As they, when they are ready, they can do this conversion. One also advantage is that you can put all your service listening on IPv6, and you can start to inject some packets directly. You start to talk over IPv6, and you see if everything is working fine. And then if it's working fine, then you say, okay, all my clients are going to send over v6, and you're putting the load. Always in lab, test environment, and then finally in production. But this is a nice way to verify that, let's make it listen on IPv6. There's no traffic going there. I'm going to inject some packets, see if it works, and then move on. Deploy and redeploy till right. So big advantage that we have. We are in a continuous deployment, so we don't have to wait for the special day of the month where a new release is going to be built. You can deploy all the time and redeploy and make fix and test it. And sometimes it's a little bit tricky because there are several dependencies on it. IPv6 ready? I hate this word. So do you think your stuff is going to work on IPv6? Oh, yeah, it should work. All right, do it. Maybe we need to re-architecture the whole things. Okay, you're not helping. You told me that by this date, then that should be done, and then suddenly we realize that it's a big mess. So with everybody, IPv6 ready doesn't mean anything. It should support IPv6 doesn't mean anything. It should work on IPv6 doesn't mean anything. Does it or it does not? Okay. Other thing which is interesting for us, for any software that say, well, it doesn't work over IPv6. Well, does it work over a dual stack machine with Quad A? Will it fall apart because there's a new protocol, or will it just say, well, I don't know this IPv6, I continue to work on IPv4? That's also something which is interesting because you don't have to deploy special machine for software that are legacy. All right, so key takeaways. First, where are we at the moment? So we've got a staging environment which is entirely dual stack with A and Quad A. So our engineers are feeling confident that their stuff is working on over IPv6. We still have some things to iron out, but people realize, well, it's not such a big deal after all. That's when you go and talk to people at IPv6, oh, I don't know these new things, that's gonna take me time, resource, and everything, and then you get there and they say, oh, that's all it was. We are going to retrofit this environment into production. No, we've got it working in staging. So say we have a data center entirely dual stack, but we need to start to put Quad A. And we are starting also to work on building IPv6 only servers, UEFI boot, BMC, etc. And which way we are going to build them. Maybe we are going first to build them on an IPv4 network and then remove the IPv4 at the end. Maybe we will have the right firmware in the time. Remember, we don't care about IPv6. We care about removing IPv4. We are not doing it for deploying IPv6. We are doing it to remove IPv4, so don't forget the end goal. We don't want to support two stack. So you have to support two stack to be able to support only one stack. That's what you have to do. But ACLs, twice the ACLs. Will your switch and firewall will be able to take twice the number of ACLs? Within how many rules can you put in your firewalls? If you have got a problem, then you have to diagnose it over v4 and v6. Is the problem due to v4, v6? Does it matter? Does it doesn't matter? No, you have to ask all these questions all the time. So it's nearly twice the work you need to deploy in various environments, etc. So what we want to do is to remove IPv4, and we want to be able to do that fast. So once you start this journey in IPv6, then that's where you want to go. Once everybody's confident, everything running on IPv6, then you say, okay, let's remove IPv4 now. That's the fun part. All right. Know the unknown very early. I don't know, it doesn't mean anything, but basically, you have to list all your software. You have to do all the inventory. I think when Cisco building 23, you have to list all the software that is running there, all the team, what are they doing, etc. Which one are going to support v4, v6? Go and talk to the vendors. Oh gosh, this is the first time you're telling me about IPv6. Common answer. Engage the vendor straight away, because if they are not supporting IPv6 and you say, well, I want it, it may take them a year, if not longer, through their release cycle to provide you the version that you need. And then still the version that they provide you that support IPv6 is not supporting the IPv6 you need.
But it's ready.
But it's ready. Or, oh yes, this interface is on IPv6, but the main protocol is still v4. Oh, okay, all right. What does it help me? So it's very important to engage your vendors and to make sure that you lay down what you need from them, what IPv6 support means for you. Don't relax and forget you have IPv6. So one of the disadvantages of IP eyeball is that it works. And your IPv6 degrade, and then nobody notices. So it's important to create case with people that will also hard fail, so that if something is not working over IPv6, people notice it and work with it. And sometimes I say we don't want any more IPv for only engineers. You have to change the culture that people start to see IPv6. When I see a slide, an example with presentation, and why is there IPv4 here? Can you do an example with IPv6? Why your example are IPv4? It's changed this mentality. Engage top-level management, you need buy-in. And it's making life easier because there's people that are enthusiastic about IPv6. Oh, I've been waiting that all my life. Let's do it. And then there's other people that say, well, once my boss is putting it on my priority list, then I'll start to work on it. So it's important to have the management buy-in so that everybody is working in the same direction and all together. And I think today we need software engineers more than network engineers. I think on the network side, we are about right. There's still a couple of feature parity that are missing on the network side, but I think we are right. We need software engineers now. We need software people that have got IPv6 and start to build it into software. That's the important part. One example, for instance, is that why do we have ping and ping 6? Why do we need two tools? Can't we have just ping? Okay, with a flag to just, I would like to test the 6th version or the 4th version, but ping should be agnostic to the network. So, and this is the kind of mentality we have. Why is the configuration of v6 is different than the configuration of v4? Is it needed, or is it something new, or I'm redesigning the stuff? No, I have to redesign all the configuration tools to fit this new version. So it's very important to have more software engineers that understand the difference. And we need to have more people to start to engage at all the software level. If we want to move all our office to IPv6 only, then we need to engage a lot of software engineers to say, well, your stuff needs to work on IPv6. And I think I'm missing the bottom is that make sure you're building AA teams. So we wouldn't have been able to get there with all the people here in the various teams, the early adopters or the people that go to meetings and ask the question, does it work over IPv6, and design and start to see the future and being able to help it. But sometimes I joke, I'm getting invited in meetings just to ask this question, does it work over IPv6? And everybody's waiting for me. So I'm very happy when somebody asks this question, so I don't have to say anything. This is where you need to go. All right, thank you. Questions? Yes, I don't know. I think, do we have to have a mic run? Micron? Micron. I don't know. Is your name Mike?
I suppose it could be. But no, I'm Curtis Clee, and would like your thoughts on monitoring. So both for performance visibility and cybersecurity visibility. And what are your lessons learned there, or approach to those areas of visibility?
Well, so we use our own, we have, over the year, develop our own tools and for doing the monitoring and bringing all this information from various platforms all together. you need to start to also to monitor, see the shift between IPv4 to IPv6 traffic. When you are doing this client service, then you need also to instrument it to know is the connection happening over v4 or over v6, and see how many QPS you are shifting from v4 to v6, and give the people the tools to be able to. Also, as you do unit testing in your software, then you put also monitoring in your system so you can bring all this information together. One interesting thing on monitoring on the, I don't know, router device, I can know how many TCP packet I do, how many UDP packet I do, but I can't know how many IPv4 versus IPv6 packet I do on the command line. So you need to have S-flows and all this kind of fancy stuff to be able to know that. Why I can't see it on my interface? Show interface. Show me how much IPv4 and IPv6 is running there. So this is this kind of, gotcha you see and say, okay, now we need to do some proper instrumentation around it. Yes?
And I have the mic already. So, Dan Augustine, a question for you. How do you convert your v4 addresses into a v6 address you said it was like deterministic, right? If you take a v4, you have a way of doing the v6.
Yeah. So, I don't know. We had a lot of discussion on that. Maybe it's the right method, maybe it's the wrong method, I don't know. But first, because we didn't do Quade, so we couldn't use the DNS to do the resolution, so we need to be deterministic. We got a system to register all the IP address, so we created a special field that allows you to link two networks together. So you can link the IPv4 with the IPv6. So knowing the IPv4 of the host name, then you know the IPv6 network that the host name will be in. We didn't want to embed the IPv4 address within the IPv6 address fully, because when you look on the interface, then it doesn't show you that it's a different format. It converts the decimal to hexa, and then you need to be proficient in do this magic to be able to read it. So, and we wanted also to be ready for the future that when we are going to have IPv6 only. So we didn't want to bring this stuff. So what we do is basically we take the last bytes of the IPv4 address and we hexadecimal them and put them as the last part of the IPv6 address. That's roughly the technique. And when you go IPv6 only, then we just need to look which one is the highest number, and +1 or something like that. So who's building an IPv6 only data center? Or who's on the way? Who's going to do that? Is it interesting? Too early?
Raise your own hand on that one.
Yeah, but...
Hi, Joe Klein. Have you heard, you may or may not have heard of DREN, which is a research group for DoD. They have the first real IPv6 only networks and data centers and such. They implemented it a long time ago, and one of the lessons learned they had was if you go to the vendor's site and they don't support IPv6 and they walk in, ask them to come back when they support IPv6 on their own website. That saved them a lot of hassle. That actually showed management commitment to getting their software to support IPv6 versus long delays of fixing some core problems.
I don't know. One crazy idea that we had was let's put IPv6 only on our guest network, so when the vendors come and demo. It's a crazy idea, but no, it's you need to support a lot of people that are coming here. But it could be fun. Yes?
Hi. David Holder. You mentioned SPF and DKIM, or at least it was mentioned in the intro. What's your policy on that regarding receiving email? Is it a mandatory policy, or is it just a part of part of all of the different checks that you do to determine if something is spam?
So it's why we play, well, the way we deploy it, we play some tricks. So first of all, is blacklisting over IPv6 is a little bit complicated. And the industry decided that if something needs to be blacklisted, it will be at the /64 level. So people that are hosting their server in an environment where everybody is under the /64, they will get pain. And we are happy with that. There's not too many people, so be careful. Don't put everything under the same /64. So it's difficult. It's not impossible. It could be a little bit difficult. So we say, well, why do we have to deal with IP address? Why don't we deal with domain name? SPF, DKIM provide us a domain name. So, well, over IPv6, we just only want to see domain name. So all your email needs to be authenticated with one or the other. And I'm not talking about DMARC and alignment stuff. Just put SPF, DKIM, whatever domain is an indicator, and we can use domain blocking list. So depending on the provider, some of them will say, well, if I can't get a domain name, your stuff goes to spam by default. Some will reject it. What we do is that we do a temp fail. And eventually, your client will find the IPv4 address to send the email to.
That's great. That's good to know, because not everybody behaves that way.
Yeah. One thing that funny that I found out once is that I put an MX record with a host name where I had only an IPv6 only address. And a piece of software that absolutely ate that. They couldn't comprehend that a host name on an MX record will have no address. Well, there's one, it's IPv6, it's a quad.
I've seen that too. Yeah.
And they will crash.
Yeah.
So
what would you say to organizations that feel they should make SPF and DKIM mandatory?
Well, we did that on
Yes,
V6.
but without
It's an industry standard from MOG. The big mailbox providers enforce it, so you don't have too much choice. If you go in mailing list, then you will see people, oh, I just switched on IPv6 on my mail server while everything is going to the spam folder. Well, you need to do that. And it's an easier conversation because they just moved. Then you can tell them, well, these are the way you need to do over IPv6. So, remove your IPv6, get fixed, and then come back. Rather than to say, well, oh, there you're blocking my emails. I will only have this problem with you guys. No, it's better this conversation.
Thank you very much.
Yeah. I would add also on IPv4, I don't know, people are looking at about 3% of email and don't have any authentication. It's part of the long tail. It's hard to say to this 3%, tough luck. It's like when we reach IPv6 deployment, then we will say to the last 5% of IPv4, well, tough luck. 5% of people is still a big number. So it will be hard on IPv4 to do it. IPv6, we've got a better opportunity to shape it. And I think that was a question from John Curran. How do you want to change policies for people to go on IPv6? It's not a technical problem, it's a policy level. What new policy you want to put over IPv6? All right.
Any other questions?
Thank you very much, and I hope that when you're going back to your organization, you're going to make phone call to all your vendors.